Hi friends, this is Rishi and welcome to your favorite YouTube channel Science with Rishi. I hope all of you are safe at your home and your preparations are also going equally well. So, shall we start? Now, accuracy, precision and error. You know what error is, right? Whenever you are measuring a quantity or whenever you are calculating some value by substituting values from different points, there is an uncertainty in that value, right? And that uncertainty is called error. Simple. Okay. Now, when it comes to accuracy and precision, let me explain it with an example. Okay, we have this pen and the manufacturer of this pen is saying that the length of this pen is 151 millimeter or 15.1 centimeter. Okay, now I am asking two of your friends to measure the length of this pen. Okay, let the measurement of A be 14.7 centimeter. Okay, and the measurement of B be 15 centimeter. Okay, here which one is closer to the original value? B, right? So I will say B is more accurate than A. So what do you mean by accuracy? Accuracy is the difference between, or it is how close is the measured value to the original value. Okay, very simple. Now to measure the precision, I am giving you two scales. Okay, one is the ordinary scale that we are using in our day-to-day life, which has got centimeters and millimeters in it. Okay, and the other scale is a type of scale which has got no millimeters, only centimeters are there. Okay, and I am asking you to measure the length of this pen using those two scales. Now, if you are measuring with the scale which has got no millimeters, there are no millimeters there, you will get 15 centimeter. Now, if you are measuring with the usual scale, you will get somewhere around 15.2 centimeter or somewhere around 14.9 centimeter, whatever be it. Here the important matter is that you can measure up to one more digit. Okay, now in the third case I am giving you a vernier caliper. I don't know how many of you have seen this vernier caliper. A vernier has got an ability to measure up to one more digit. Okay, now if you are measuring by a vernier, you may get some value like 15.18 centimeter or something like 15.21 centimeter or something like that, which means the number of digits has increased. Okay, this is vernier, this is scale, this is also a scale. Now let me give you one more instrument, screw gauge. Screw gauge can measure up to one more digit. You will get something around 15.178 or 15.207, etc. Here in these four different cases, you can see the extent up to which you can measure is increasing, right? This can measure only up to centimeters, this can measure up to millimeters, this can measure up to 1/10th of a millimeter, and this one 1 by 100th of a millimeter, I will say screw gauge is more precise because it has got the maximum extension, the maximum extent up to which you can measure a quantity. Okay, so that is precision. Okay, here something you have to remember very carefully, or this concept must be very clear for you. See, our original value is 15.1. While the scale A gave us a measurement of 15, B gave us a measurement of 14.9. Okay, so here which one is accurate? Of course it is A, because the value of A is closer to the original value compared to B. But which one is more precise? It is B. So always don't think that the instrument which is more precise will give you the more accurate value. Okay, they are completely different things, accuracy and precision. Okay, now coming back to errors, you know what is an error? The uncertainty in the quantity, right? So what is causing this uncertainty? Whenever we are measuring something, we are not sure that okay, this is 100% sure this is the correct value, right? There can be some error, right? And what is the cause of all these errors? That is the next topic that we are going to discuss. The set of errors you can divide into two: systematic and random. In the systematic errors, we can divide that itself into three parts: instrument error, technique or procedure, or personnel. Instrument error, as the name suggests, it is because of the error in that instrument. Suppose you have a thermometer. Okay, we all know that water boils at 100 degrees Celsius. While if that thermometer is showing you 102 or 103, that means that instrument has got some problem in it, right? And all the errors arise due to that problem in that particular instrument is called the instrument error. Now, imperfection in technique or procedure. Knowingly or unknowingly, you are doing that particular experiment in a wrong manner. I hope all of you have did the simple pendulum experiment in your 9th standard or something. There, your teacher has asked you to take the time for 20 oscillations, but you are just taking it for 10 oscillations, okay, knowingly. That can cause an error. Okay, such errors which can occur because of the imperfection in doing that particular experiment, that comes in the second category. Now the personal errors. See, the way I do an experiment, you or your friend do an experiment may be different. That is actually dependent upon the behavior of each and every person. I may have a close look at it, but someone of you may have a quick look, okay, this is the value. Right? Such thing can happen, and that can vary according to the person. And that can influence the readings also. Such errors come under personal errors. Now coming to random, as the name suggests, they are random errors. Something unexpected or something which you cannot expect, this will happen in that experiment each and every time you are doing it. Such errors comes under this random experiment. Suppose you are doing an experiment where you have got a digital instrument where you are reading some values on the screen. Okay. Now some problem occurred for that instrument and it is showing a lesser value than expected. You cannot expect that damage each and every time you are doing that experiment, right? But unfortunately it happened at this time. Very good time, yeah. So such errors comes under random errors. So in brief, you can divide errors into two, systematic and random. Systematic, you can divide it into instrument, imperfection in technique and procedure, and personal. And random, they are random errors. Now we are very strong with the theory part, right? Now it's time for us to apply it into the practical mode. You are asked to measure some quantity. Okay, say let the diameter of this pen. Okay, now you are measuring it n times. Let it be around 5 or 10 times. Okay, you are measuring A1, A2 up to A10. A1, A2 are all the different values that you are taking. You are taking the same diameter 10 times. Okay, we are denoting it as A1, A2 up to A10. Okay, now let us take the mean of all these. Okay, A1 plus A2 plus etc. up to A10 divided by 10. Now you got a value which is a mean. And in the next step, we are subtracting this mean from each and every values. Okay, and we are denoting it as delta A. So what is delta A1? A1 minus A mean. Okay, like that, delta A10 equal to A10 minus A mean. Now you have 10 delta A's, right? Delta A1 up to delta A10. Their absolute values. Okay, what do you mean by absolute value? A value without its sign. Absolute value of minus 3 is 3 and absolute value of 3 is also 3. So the values without that mark, they will be always positive. Okay, these values are called absolute errors. Okay, they are called absolute errors, and their mean, okay, delta A1 plus etc. plus delta A10 divided by 10. This is called mean absolute error. Okay, the mean of the absolute errors. Okay, and this is denoted by delta A mean. Relative error. Relative error is delta A mean by A mean, and percentage error is this value, delta A mean by A mean into 100 percentage. Okay, so while doing an experiment, we are coming across 4 terms. Absolute error is what? The difference of each and every value from the mean of those values, their absolute value. They are called absolute errors. Their mean is called mean absolute error. Okay, and which is denoted by delta A mean, and delta A mean divided by the mean of all those values is the relative error, and that one into 100 is the percentage error. Now in example 2.7 given in your textbook, it is just the direct application of these things. And now we know what is A mean and what is delta A mean, right? Now we represent the value that we have measured, for example the diameter of this pen, okay, as a mean plus or minus delta a mean, which means the value can go minimum up to a mean minus delta a mean and can go up to a mean plus delta a mean. Understood? Very simple. Now suppose we have two values, say a plus or minus delta a and b plus or minus delta b. Okay. Now what will be the error in the resultant if you are adding, subtracting, multiplying and dividing these two values? That is the combination of errors. Now let's take the first example. Okay, z is equal to a plus b, which means z plus or minus delta z equal to a plus or minus delta a plus b plus or minus delta b. So let me rearrange it. A plus b plus or minus delta a plus or minus delta b. Okay, so whenever you are adding two values or two quantities, the resultant will be having an absolute error which is equal to the sum of the absolute errors of these two individual quantities. Okay, these two are the absolute errors we know. So delta z will be equal to delta a plus or minus delta b. Okay, now let's take the second case, a minus b. Okay, a minus b, which means z is equal to a minus b and a plus or minus delta a minus b plus or minus delta b gives you z plus or minus delta z. Okay, now let me remove this bracket. A plus or minus delta a minus b. Now what is minus of plus or minus? Minus of plus or minus, let's take an example 5, is minus into minus plus and minus into plus minus. It is plus or minus 5. So here it is plus or minus delta b itself. Okay, now let me rearrange it. A minus b plus or minus delta a plus or minus delta b. So what you can conclude from this? From the addition part, the only difference is that this became minus, but the error part, that is still the same, which means in both addition and subtraction the absolute error of the resultant will be the sum of the absolute errors of the individual quantity. That is same for both addition and subtraction. The only difference comes is at this part. Okay, in the sum this was a plus b and in the difference it is a minus b, but the absolute errors are always the sum. Okay, now the third case where it comes to multiplication. Z is equal to a into b and z plus or minus delta a is the product of a plus or minus delta a and b plus or minus delta b. Let me expand it as if we expanded x plus a into x plus b. Okay, so what is this? ab plus or minus a delta b plus or minus b delta a plus or minus delta a delta b. This is Z plus or minus delta Z. Now let's divide the whole term, both LHS and RHS, by AB. Divide by AB. Z by AB plus or minus delta Z by AB equal to, what is AB by AB? It is 1. Plus or minus A delta B by AB. It is delta B by B. Plus or minus B delta A by AB. It is delta A by A. Plus or minus delta A delta B by AB. Now see that last, this one. We know both delta A and delta B are very small. So their product will be further as a smaller value, and divided by AB means that one got again reduced. So let's neglect that term. Okay, we are neglecting this term. And we know Z divided by AB means Z is equal to AB. So Z divided by AB is 1 plus or minus delta Z by Z equal to 1 plus or minus delta A by A plus or minus delta B by B. Now let's remove these two 1. So what did we conclude? Delta Z by Z equal to delta A by A plus or minus delta B by B, which means in multiplication the relative error of the resultant will be the sum of the relative error of the individual quantities. Okay, there it was absolute error. This divided by term was not there. Now here the divided by term came, by which this became relative errors. Okay, the sum of the relative errors of the individual quantities is the relative error of the final quantity. This is applicable for multiplication and division. So what is Z equal to A into B? In that case, what is happening? Delta Z by Z equal to delta A by A plus delta B by B, right? So now the fifth case, what if Z is equal to A square? Okay, very simple. A square means A into A. So instead of B also another A is coming. So if Z is equal to A square, then delta Z by Z is, instead of B also you can write A. So delta A by A plus delta A by A. So 2 into delta A by A, which means this power has come here. Okay, this is 2, this one has come here. Now if it is A cube, another A will come. So this will be 3 into delta A by A. In general, if Z is equal to A raised to P into B raised to Q divided by C raised to R, then delta Z by Z is equal to P into delta A by A plus Q into delta B by B plus R into delta C by C. Although here C is coming in the denominator, you don't have to take that one into account. You can just write everything plus. Okay, the simplest way of keeping it in your mind. That's it for today. Before we wind up, a quick recap. We have studied what is accuracy, what is precision, and what is error. We have gone through what are the different types of errors. We have seen what is mean error, mean absolute error, relative error, percentage error, and we found out how we can write a quantity in the terms of a plus or minus delta A, right? And last, we have seen how the resultant will vary when we are carrying out different operations: plus, minus, multiplication, division and exponential. Okay, I think my classes are useful to you. You people are getting some benefit out of it. Any comment or anything you have to convey me, you can just write a comment below the videos and I will be answering for that. So see you for the next video with a new different topic. Until then, Rishi signing off. Bye. Take care. Jai Hind.